This is my second video lesson for Unit 9. In this lesson, we'll be calculating the atomic mass of an element. Go to page 7 in the class packet. To help you understand the calculations involved in atomic mass, we're first going to look at an analogy. Here is someone's grade on Jupiter. Here's the breakdown. Calculate the average of the student grade. To calculate the average of the student grade, you have to multiply the grade by the percentage, then add up the 5 components to get the average. I color-coded the grade and the percentage. The grade is blue and the percentage is purple. The average of the student grade on Jupiter is 84. Here's the equation. The percentages should add up to 100%. The atomic mass calculation will be similar to this. Learning target. At the end of the lesson, I'll be able to calculate the atomic mass of an element using mass and percent abundance. Homework B number 2, which will be a Junipod based off this lesson. Atomic mass is the weighted average of all naturally occurring isotopes. The average only includes naturally occurring isotopes. That means isotopes that you find in nature, no artificial isotopes. Here we have the atomic mass of neon. It is 20.180. So here are the 3 naturally occurring isotopes of neon. Since this number is an average, are there equal amounts of each isotope? The answer is no. Notice that it's closer to the number 20 than 21 or 22. Therefore, there must be more of neon 20 than neon 21 and neon 22. Here is the actual percentage of each neon isotope in nature. As you can see, neon 20 is the most abundant. If you add up all 3 percentages, it adds up to 100%. This is known as percent abundance. It's the percentage of each isotope in nature. Here's the equation for the atomic mass calculation. The equation is very similar to how you would calculate your average grade on Jupiter. M stands for mass, so M1 will be the mass of isotope 1, M2 will be the mass of isotope 2, and so on. A stands for percent abundance, is the amount of the substance relative to other substances. So A1 will be the percent abundance of isotope 1, A2 will be the percent abundance of isotope 2. The dotted line represents the number of natural occurring isotopes of the element. So this equation can keep going depending on how many naturally occurring isotopes the element has. Keep in mind, if you take the sum of all the percent abundances of each isotope, it should add up to 100%. Here's another form of the same equation. You can use either one. On the regions, make sure you know how to write a setup of the atomic mass calculations. Let's look at example 1, boron. Boron has 2 naturally occurring isotopes, B10 and B11. Here are the natural abundance. The first step is to figure out the mass of each isotope. We can determine this from the mass number. So B10 have a mass of 10 AMU, B11 will be 11 AMU. Next, we plug into the equation. This will be our setup, 10 times 19.9 plus 11 times 80.1, divide the whole thing by 100, gives us 10.801. This will be the atomic mass of boron. This value is very close to the one on the reference table. Learning check number 1. The atomic mass of an element is the weighted average of the atomic masses of what? Pause the video and resume once completed. So this is a definition question. So the answer is choice 2 because it must be natural. It cannot be artificial. Learning check number 2. The table below gives atomic mass and abundance of 2 naturally occurring isotopes of bromine. Which numerical setup can be used to calculate the atomic mass of the element bromine? Pause the video and resume as completed. So the answer is choice 3. Learning check number 3. A sample of element X contains 90% of X35 atoms, 8% of X37 atoms, and 2% of X38 atoms. The average isotopic mass is closest to what? Pause the video and resume once completed. X35 is the most abundant isotope of element X. It is 90%. Therefore, the answer is 35, choice 2. Now try to complete the following practice, A to I. Pause the video and resume once completed. Here are the answers. This concludes the video lesson. Remember to do the Junapod homework.